I want you to imagine we could crush everything, every star, every planet, even you, into a space smaller than a single atom. A place where time and space literally just stop, and the laws of physics completely break. This sounds like science fiction, but it's real. It's called a cosmic singularity. It's what we think is at the bottom of every black hole, and it's how our entire universe got started. These points of infinite density are the absolute limit of what we know. It's like the universe is putting up a giant sign that says, "You don't know anything." So what's the deal? Today we're going on the most extreme trip possible. We are going to the heart of a singularity to explore what scientists think is happening at the very edge of reality. No one, the edge of physics. To understand this insane concept, picture space-time as a giant trampoline. A star makes a little dent in it, and that's gravity. Now, imagine something so heavy it doesn't just make a dent, it rips a hole right through the fabric of reality. That hole is a singularity. According to Einstein's own theory, this is where everything breaks. The math that runs the universe just starts screaming infinity for things like density and temperature. It's not just a ton of gravity, it's a number so big our math can't handle it. Here, the rules we've relied on for 100 years just completely shatter. This happens because we have one set of rules for giant things and another set of rules for tiny quantum things. At the center of a singularity where everything is crushed together, those two rulebooks have to collide. The problem? We don't have the official rulebook for that collision. We're missing a theory of quantum gravity. Without it, a singularity is a complete mystery box. No two. The journey to the center. All right, challenge time. We're diving into a black hole right now to get to the center. Our first stop is the event horizon. Think of it as a cosmic waterfall you can never escape. Once you go over, you're never coming back. The gravity is so strong that even light can't escape. Inside the event horizon, things get insane. The direction to the singularity isn't a place you go to, it's the future. Every single possible path you could ever take forces you there. You're not falling through space anymore. Space itself is falling, and it's dragging you with it. As we get closer, the gravitational forces are ridiculous. You'd get hit by spaghettification. The gravity at your feet would be so much stronger than at your head that you would be stretched into a literal noodle of atoms. It's as weird as it sounds. But let's say we could survive that. What happens when we reach the absolute center? This is where our trip gets 100% theoretical. We arrive at the singularity. And here, our journey just ends. Not because we stopped, but because the path itself literally stops existing. The fabric of space-time is torn. The road for anything and everything just ends. No three, the shape of infinity. So what does this infinity point even look like? Is it just a dot? Well, our theories say there might be two different kinds. For a boring, non-spinning black hole, the singularity is just a single tiny point where all the mass is crushed into zero space. But what if the black hole is spinning, and most of them are? Then it gets even crazier. The theory says the singularity isn't a point. It's a ring, an actual ring of infinite density. This is where people have some wild ideas. Because the ring has an open center, some have theorized you could fly right through it, missing the deadly edge. And where would you go? Maybe to another part of our universe or a completely different universe in a wormhole. But don't get your hopes up. This is basically impossible. The insane radiation and instability would vaporize you instantly. This stuff is absolutely insane, and if you want to see more of the craziest science in the universe, hit that subscribe button right now. We go big every single week, and I want you to be here for it. No 4, the other singularity, but black holes aren't the only place you find these insane glitches in reality. Our universe's own birth started with 1, the Big Bang singularity. If you hit rewind on the entire universe, everything, all the galaxies, all the stars, would fly back together into a single tiny point. According to the model, 13.8 billion years ago, everything that exists was packed into a spot of unbelievable density and heat. From there, space-time itself exploded. This wasn't an explosion in space, it was the explosion of space. Before it, there was no before. Time literally did not exist. It started in that exact moment. And just like with black holes, our physics completely breaks. We can describe what the universe was like a tiny fraction of a second after the Big Bang, but we can't describe the instant it was born. To do that, we need that missing rulebook, a theory of quantum gravity. No 5, escaping the infinite. Okay, let's be real. Scientists hate infinities. An infinity in an equation is a giant red flag that the math is broken. So what if singularities aren't actually real? What if they're just a ghost in the machine telling us our science is incomplete? Some of the smartest people ever proved that singularities have to exist. But here's the catch. That's only true if you're using Einstein's rulebook. This is where new ideas come in. Many physicists think that as you get close to a singularity, quantum effects would take over. Instead of a smooth fabric of spacetime, you'd find a chaotic foam of quantum energy. Some theories say this quantum pressure would fight back against the collapse. Instead of crushing into an infinite point, matter gets crushed down to a ridiculously dense, but finite, state, and then bounces. In this big bounce idea, our Big Bang wasn't the beginning. It was just a rebound from an old universe that collapsed. And inside a black hole, matter might not be destroyed, but might bounce to create a brand new baby universe. These are crazy ideas, but they give us a way out of the infinities that break our theories. No 6, the cosmic censor, so are singularities real or not? Who knows? But the universe seems to have one simple rule for them: hide them. A physicist named Roger Penrose came up with something he called the cosmic censorship hypothesis. And it's simple: every singularity must be hidden behind an event horizon. No exceptions. This is a really big deal for us. A naked singularity, one without an event horizon that we could just look at, would be an engine of pure chaos. It would be a place where the laws of physics are broken, spitting out random information and making the entire universe completely unpredictable. Thankfully, it seems like the universe doesn't like showing off its glitches. While we still don't know for sure if naked singularities can exist, most theories say they're too unstable. If one formed, it would probably suck in matter so fast that an event horizon would instantly form around it, turning it into a normal black hole. The universe, it seems, prefers to keep its craziest secrets hidden from us. So what actually happens during a cosmic singularity? I'm going to give you the 100% honest answer: nobody knows. It's a wall. It's the point where our best theory of gravity just gives up. These things are hiding at the center of every black hole and at the literal beginning of time, and we can never, ever see them directly. To finally solve this mystery, we need to discover the ultimate theory of quantum gravity. That's the only way we'll know for sure what happens when space-time gets pushed to its absolute limit. So what's on the other side? A brand new universe? The ultimate end? We don't have the answers yet, and that's what makes this the biggest challenge in all of science. The mystery of the singularity isn't a failure, it's a signpost, pointing us to the next massive discovery in our understanding of the cosmos.